remember? Is IC equal to GMVB equal to beta IB, then GM equal to IC by VT. Okay, can we start? Okay, can I have your kind attention, please? We're going to restart. But I think we don't want to use blue anymore. We want to use another color. Getting monotonous, isn't it? Green is can't see it. Black. Orange. Black. Orange I don't have. I used to have orange, but they don't supply me. Unless you are willing to supply accessories to the university. Yeah, so, John did a very good job in putting down the AC equivalent circuit with the AC small signal model. So make sure you understand this, what John did. This is the correct form of it. And from this you can do the small signal analysis. So what I'm going to do is I'm going to erase all of this. I don't think we need this anymore. So if you see it here now, this looks a bit complicated, but you can actually make it look more simpler by looking at this. You see, you have V in across here. This resistance is very low. This is 1/GM is very small usually. About 20. When you do a practical problem, you'll see that 1/GM is very small. This RB is how much? 900 kilo ohm, remember? Very large. So this, for all practical purposes, when you have RB in parallel with 1/GM, you can remove it. So that will make your circuit bit simpler. So you'll remove the RB and keep your voltage source only, which is V in here at the input. And here you have your 1/GM. Just put your 1/GM. And then at that point you have a current source. You have this current source here. So you just put this current source. It's better to make it flat, If you make it flat, it looks a bit simpler, This is your IC equal to beta IB equal to your GM into VB. This is your base. This is your emitter here, grounded. See, the emitter is grounded here. So emitter is grounded. This is both AC and DC ground. It's grounded here. This is the emitter here. So this is grounded. And at this point, what you have, these two resistors. Is RC and RL in parallel? Yes. This is ground, this is ground. You can see they are parallel. So if you bring them parallel, it will look easier for you. So bring them parallel. RC. Okay. So from there, this looks a bit simpler. Okay. So your V in is here and your V out is here. So your V in is here and your V out is here. Okay. And can we simplify it a bit more? We can combine these two together with one resistance. So we can simplify a bit more. You put your current voltage source here, V in. Your ground is here. Ground is here. 1/GM here. Your current source here. IC equal to beta IB equal to GMVB. And here you have just one resistance now going to ground, which is RC in parallel with RL. Okay. Okay. So now it's even simpler, you see. V out. So now to reduce the expression for the voltage gain we express by AV. This is called voltage gain. And when we say voltage gain, we mean small signal voltage gain, AC voltage gain. Okay? So voltage gain will be equal to ratio of output by input, isn't it? So what is here? V out, isn't it? V out. And what is here? V. Okay. So what is your V out? So if you look at it carefully, this is the collector current, and there is nothing else connected here. Is there any current flowing here? No. So the current is flowing this way. It is flowing this way. This is your IC flowing this way. V out, when I say this is V out, then this is plus, this is minus, isn't it? When I say V out here, that means this is plus, this is minus. But the current actually is going against the voltage. The current should go this way, but the current is going this way. So V out is the product of minus IC into RCRL, because the current is going the wrong direction as per our symbols, you know. So V is equal to V out is equal to minus IC into RC in parallel with RL. Okay? This is your V out. This current, the current that is flowing in the wrong direction is IC, so the correct direction current is minus IC. Okay? So correct direction current is minus IC this way, minus IC. So minus IC into RCRL is your V out. Okay? So you put on top your V out, which is minus IC into RC in parallel with RL. Okay? And what is your V in? This V in, what is the voltage? What is the current flowing through here? What is the current flowing through here?
IA.
IE. Exactly. Current flowing here is IE, which can also be called approximately equal to IC, because IB is very small, which can be called IC. So what is the voltage V in equal to what?
IC over here. Sorry,
IC into 1 upon GM. This will be in. So emitter current. So if you look at, this is the VBE, BE. The emitter current is flowing in the correct direction, so there is no need of a negative signal here. Please don't use mobile phones. Don't use mobile phones. Don't look at your messages now. You know, this is the message for now. This is the message. This is the correct message for this correct moment. So this is your IC into 1 upon GM, IC upon GM. So in the bottom you write your V in, which is IC into 1 upon GM. Okay. Again, what are the? I told you just now that don't look at more. No message. You switched. Oh, you did a great job. You switched off. You did me a great favor switching off. That's the kind of student we want, who switches off the mobile phone. Okay. So now what we do is that we cancel. Can we cancel IC top and bottom? Can we do it? Okay, so we'll do it. And then this is equal to minus GM will go upstairs. GM into RC in parallel with RL. Okay, so this is your voltage gain. So this is your voltage gain. Okay? Small signal voltage. So how do you start the problem? You're given a problem which you start by solving the DC equivalent circuit. Find the bias point, find the GM, find the AC equivalent circuit, insert the T model, find the AC analysis, input the value. So if your values are given, you could put RC here, RL here, GM here, then you get your output. Okay? So if you have an examination problem like that, don't try to directly use this. Don't try to memorize this and directly do it. You should try to solve it from the circuit. because there may be small changes in the circuit which can cause your final equation to be different. Okay. So as the circuit changes, the expression for the small signal gain can change slightly here and there. Okay. So if you do it at home anytime or during exam or during preparation of exam, do it clearly starting from the DC model. Do every step until you get to the final step. Don't use formulas, unless you just want to find out this. This formula is never going to change. This is always going to be to ICQ or VT. No matter how many, if you put a resistance here, no matter what you change, this is not going to change. If I put a resistance here, this is not going to change, but this is going to change. See, this gain equation will change if I put a resistance here, but this one is never going to change. Okay, some equations never change. Some equations will change. Okay. So this is the process. So have you written down all of it? Everybody? Then now what I'm going to do is that I'm going to go into actual problem with all known voltages, known resistances, and actually we are going to solve. So I would understand that now you know the entire step, so I don't have to do anything for the next problem. You can one by one come and solve the problem and make our life easy. Sounds good? Yeah? No? Sounds good, Jay? Yeah. So do I need to keep anything on this board? Can I erase all of this? Yeah. Can I erase all of this? So I'm going to erase everything now. Start blank with a new problem based on these information. Okay, so let us create a problem and then solve a problem. Okay, create a problem is create a circuit. So say you have a circuit that we try to solve. Now in the same one, I am going to make it a bit more complicated after we solve this one. Okay, so this one is RB, and this is a bias voltage here. Say this is 10 volts. And then we have a transistor, and as we have discussed in the lab and elsewhere, that the beta is characteristic of the device. Beta never changes. What is the difference between beta and GM? As far as the characteristics concerned, beta is characteristic of the device. Once you fabricate the transistor, the beta will not change. Unless you actually heat it up or really destroy it, do something to it that it doesn't really like at all. Then you will have changed this beta, and you won't be able to use it much. Whereas the GM is not dependent on the fabrication. GM is dependent on the bias current that flows through it, which depends on the circuit that you design, because it depends on ICQ. That is the bias current that you allow to flow because of the way you bias the circuit. So GM is dependent on the circuit. Beta is not dependent on the circuit. You can create a circuit to measure the beta, but beta will never change. Okay? So here I give you beta. How much beta you want?
100.
120 beta. Make a compromise. Okay, and then you have RC. So RC maybe I give you so that you know how to draw the load line. So I'll give you RC, say 6 kilo, and then I give you supply voltage so that you know from where to start. You draw your line from the bottom. So say this is 20 volts. Okay. So for this, find everything. Find bias point, find gain, okay. Find RB, find bias point, find RB, find gain, find all of this. That means to find all of this, you have to go straight actually from the IC set and DC off, that is when you saturated, to get those 2 points, and then draw the load line, find the middle point, find your bias point, find GM, then draw the AC equivalent circuit, then insert the T model, then do the AC analysis. So everything that we have done little while ago, algebraically, now you have to do it in arithmetic. Okay? So, because I understand everybody have understood last time what we did, everybody now knows everything what to do. So we can start by somebody solving for us the DC equivalent and providing us the bias point. So who can do it? You can do it? No? Who can do it?
Don't we need a V in?
V, yeah, we need a V in. So I'm going to, okay, I didn't give that. So I'm going to produce the small signal. I'll give you the small signal inputs, and the load also, so that you have the basis for the small signal analysis. So you, as we have shown before, we'll have a V in here. This capacitance, of course, doesn't really matter what value. It's a large value, so that it will have zero resistance across it. And then we put another one here, a capacitance, and then we put another resistance here, load. Say this is 5 kilo. So you have this load known, this RC known. So we give it a name also. This is RC, this is RL, this is V in, this is RB in. Okay. You can have the option of solving it yourself first and then showing us how to do it. So you can start solving it now. So solve the entire problem based on what we discussed a few minutes ago. Complete the entire problem. So you better do it step by step. Don't use any equation. First draw the DC equivalent circuit, then do the DC analysis, then go to AC equivalent circuit and do the AC analysis. So remove this, and draw your DC equivalent circuit first before you proceed to the AC part. So how much is the RB? Have you found your RB?
669.6.
RB how much?
You hit it out? Oh, you still checking out.
How much is RB?
I got 720K, but it's
Yeah,
not that.
it's somewhere there.
334.
Eh?
334.
How do you do it? That's the first question.
Okay, so you can go L 2.5 but it's probably done around here.
Okay.
Rangi, you want to do this one? Okay. Friday is your chance then.
I don't want to do.
Why not? You know, everybody's doing, you know.
Everybody's doing it.
I think Rangi will do the moss. You like moss more, isn't it?
Oh no, I'm looking at the game. What are you? Of the game.
Finish?
I'm pretty much
Yeah. You want to do it? Okay.
5 over 2 times 2 like this next case. It's surprising except we got. I don't know yet.
Because you are amplifying. If you get points after that, if you are attenuating.
Well, he got this, but he got it.
Whenever you get points after, you mix it.
Oh yeah.
So first draw the DC equivalent circuit. Draw the DC equivalent circuit and then progress. Yeah.
I'm not sure. I don't think
What is the name of your program? Abhi is showing you how to do it. Okay, please pay attention.
it's negative that. Just double check. It's negative. How can negative be bigger?
It's 20. It's also your operation currency.
That's what?
Finding the gain through the whole thing.
Finding your gains, you gotta go to gym.
Go to this, right?
Yep. Just leave it at a fraction. Yep.
What is the load line? You have to draw a load line. Don't use formulas. Don't use formulas. Never use formulas. Load line. Yeah, load line. Draw the load line.
Take your time. Just so let me get this right. For our average day, let's if it's bigger and it's bigger than 1,000. And but that's one point scale.
Never use formulas. You solve the problem gradually. Don't use formulas.
This is all today.
Yeah, all today. Well, you should have written down the G equation. Yeah. DC equivalent.
Just a while ago,
See, write a bit larger, you know. Bit larger. Next one you draw, write a bit larger.
Yeah, I see what you mean. All right.
which is also equal to BTC over 2 times plus BT over 2 times.
Equal to how much? Write down. 5K. Let's put 5K. And then 6.
Every time you see you can do it, Amina. I believe.
Use small signal model in.
Small scale.
With the small signal model. T model. Just put.
That's the only way I'm doing it.
It has to be there.
Yeah, replace this with T model. Replace the whole thing. Put the whole thing together. Including the T model.
It's the same.
Please pay attention. Don't pay attention. What Avi is doing. Do you understand what he's doing? Hope is not enough. You have to understand fully. You got it?
He's writing some ancient hieroglyphs. He's writing ancient hieroglyphs. Ancient hieroglyphs.
Like the Egyptian hieroglyphs.
Avi, can you write this larger? And then you ground look like you ground. You see your ground.
They look like tomatoes.
No, your grounds look too good. You know why? Because your ground look like there are worms there. You know? So make it.
Very nice. Very nice.
Yeah, because I put the natives with the IC,
Okay, put the value of RB. How much is RB? How much? Write down. How did you get the RB?
Yeah, so this is what really, yeah, this is what. If you have a negative because you're does that mean if you're making this figure 4 and you're shrinking it, then it's going to be negative again? Because you're
This is
doing
ICQ is 1.6. ICQ is
will it even be right? Will it even be a negative? You can have a negative?
When you drink water.
I was just thinking it'd be really cool if that was the case.
So it will make a difference because RB is yes. It won't difference. It won't make any difference in responsibility. Because RB in any case will be large compared to
Yes, because we need to go. I see a question and then the positive
minus 47 squared by against then minus 45 then RB equals to exactly 10 minus 0.7 divided by IB. How much is this? How much is this? Can you calculate? 1.167 by 120. How much is this?
It's 1.38888, I think.
Why is it one?
That's not what I got.
This side? Half of that is how much?
1.67.
Yeah, there's no one. Yeah, almost got a heart attack.
Yeah, natural.
So this is 1.67, is it? Yeah, 1.67. So 1.67 over 120. How much? 1.69 over 120, how much?
Zero point zero one three nine.
Put it here. So how much is RB? 6769? Eh?
RB is 669.6.
669.6. 9.6 kilo. Okay. Then the voltage gain here. So voltage gain will come from here. So you put your output here, output here. So this is your input and this is your output. Put the value here, 669. 6K. Okay, take put K. And then put your V out. Okay. And then what is V out by V? That's okay. V out equal to your IC. Okay. Just V out equal to your minus IC. Minus IC into 6K parallel with 5K. 6K parallel with 5K how much? 4.5K? 6K parallel with 5K how much? 4K?
Sorry, 6K parallel.
5K how much? 4.5K? 2.7 half of it.
Yeah. Which is like 2.727%. Something like that.
How much is it? If you had 6 and 6, it will be half. 3. So now if 6 and 5, it will maybe slightly less. 2.7? 2.7?
2.7 kilo.
2.7 kilo. Okay. And B in is how much? This is V. Okay, you calculate this is equal to how much? And B in is equal to? B in equal to what? So what is the 1 upon G? 1 upon G is missing here. Okay, so V in equal to 1 upon GM into IC. 1 upon GM into IC. Okay, now you write your V out, your voltage gain equal to. Okay, that's done. Now write voltage gain. Equal to V out divided by V in. Okay, V out equal to that on the top. Divided by, just put, yeah, you can put 1 upon GM now or later on whenever you wish. 1 upon GM. Is this correct? Is this correct?
Yeah.
1 upon 0.064.
Okay, so
Okay, so go there and this will go up, so you don't have to worry.
that would mean that in this equation.
IC you don't need because IC will cancel out the bottom. This into IC. Okay, you put already.
Okay, so I kind of.
Okay. So now how much is the gain? 174?
174.83.
Yeah.
Minus sign? Thank you. Although we have to help him a bit in the way, with the help from these 2 guys, you know. 3 guys. And backup from Ishka. We managed to help put him through. Okay? So, this is enough for today. You want to continue?
Yes, 1 more hour.
So you can stay here if you want to. Okay, so I'll see you on Friday. And we'll see you in the lab tomorrow, 10 o'clock.
Yeah. No. No.
Is it? I don't know if that's sort of.